Hello friends, hello students. I am Jagan Babu, Assistant Professor, working in RMD Engineering College and Autonomous Institution in Department of ECE. I am handling this DSP subject for present third year students, even semester, that means 6th semester. It's a 4 credit subject, problematic paper. Though DSP will be one of the tough subject students' point of view, so need to learn more concepts and set of problems. The prerequisite of the DSP subject is signals and system. Why signals and system? Students should learn all the direct form, realization such as direct form 1, direct form 2, lattice structure, parallel form, cascade form, polyphase structure, etc. Then students to understand all the transformations, Fourier transform, Laplace transform in continuous, Z transform and Fourier transform in discrete time. Though our subject is digital signal processing, DSP, so we'll understood only the discrete time signals, that is a discrete Fourier transform and Z transform. Next, the students are able to understand impulse response. What is mainly impulse response? Though we need to know about what is maybe convolution. Though we need to understand the convolution topics based on the linear as well as the circular convolution. In signals and system, they studied only the linear convolution, that is called as a linear convolution sum, or basic convolution, that is the integration and the summation. Once convolution learned, they'll be understanding what is the impulse response concept, h of n. Then very important word is frequency response concept, h of j omega or h of e power j omega. Then you need to understand what is signal, what are the types of signal, then what is system, what are the types of system. All the basic fundamental concepts, once you are clear, then you need to enter into DSP subject. Then only the subject will be very easy. Today we are going to discuss unit number 4, finite word length effects, which is called as a FWLE. My output will be in analog. Before it will be digitized, all should be in binary form. Let you know about the number representation concept. There we have a fixed point representation, floating point representation, block floating point representation. There you need to understand, there we are studying the signs magnitude 1's complement and 2's complement. All the fundamental concepts in number representation is very much helpful for the finite word effect lengths. Once input data is ready, it is be sampled and quantized. Before going to quantization, the sampling. Once sampling part is over, come to the quantization. That topic we are going to discuss today. The topic is steady state input quantization power. So my state will be steady state over there in the input area. So quantization. Okay, I'm going to calculate the power. Once the word power came, you have to remember all mean formula, variance formula, expectation of. You have to remember, recollect the probability and random process subject, mathematics, conditional probability, distribution probability. Quantization error commonly views as additive noise system. X of t is sample by sampler, it becomes x of n, that is nothing but x of n into t. Capital T is nothing but total time. Now error, that is called E of n, is been multiplied with the signal achieved by x of n by the adder. Then you get the answer as xq of n. X of t becomes x of t in continuous time becomes x of n is discrete time. Now if x of n discrete time belongs to the xq of n. X of n belongs to the xq of n, which is nothing but discrete signal. Then now that discrete signal is quantized signal. X of n becomes xq of n. X of n becomes xq of n, where xq of n is equal to x of n plus e of n. We have the derivation for the input quantization power in terms of concept called quantization. The quantization we have two types. One is called truncation, other one is called rounding. First we talk about the rounding concept. E of n is equal to minus q by 2 less than equal to E of n less than equal to plus q by 2. The range is given for the signal, error signal, minus q by 2 to plus q by 2. Then sigma e square is equal to expectation of, that is called E square of n minus E square of E of n. which is equal to mean square minus mean square. E of E square of n is minus average of E square of n. E of n minus mean value of E of n. That's the they differentiated and splitted the terms into both the different values. Next, E of E square of n is equal to, we have the formula integral of minus infinity to infinity E square of n P of E dot d. P means power. P of E is equal to 1 by q. I take in the quantization level, sample is 1 by q. Ranges E of n equal to minus q by 2 to plus q by 2. E of E square of n, substitute the limit in terms of minus infinity becomes minus q by 2 to plus q by 2 E square of n dot P of E substitute as 1 by q into dE. So I take 1 by q outside, integral minus q by 2 q E square of n dE. Mean is 0, therefore E square of n dE, if you substitute it, you will get the answer. This is a q value 2 divided by 2 power b plus 1, which is equal to 2 power minus b bits. Therefore, you get the answer of sigma E squared is equal to 2 power minus 2b by 12. This is important for the problems. Thank you, students. We'll see more videos in the next one.